Good afternoon and welcome back to Tyrolit Tool School. Today the topic's gonna be carbide burrs. Now, as always from our side, if during the explanation, if you have any questions, please use the Q&A to ask your questions and we will try to answer them as quickly and as good as we can. So, carbide burrs. Carbide burrs over the last year have been developing more and more and are being used more and more in metal applications. When I say metal applications, then it's going to be a wide variety of different materials that can be worked upon with carbide burrs. That can be normal steel, that can be hardened steel, that can be hardox, that can be stainless steel, special alloys, and also, not to forget, aluminium. So carbide burrs have been upcoming more and more. Now, for all those different materials, what do you need? You need a special cut. You need a special cut to work on different materials to get the best result of your carbide burr. But I'm getting a little bit ahead of myself because I need to perhaps explain what is a carbide burr, how is it made, what are the components that are necessary or required to create the Tyrolit carbide burr. Now, the first component that we need, as the name does say it, tungsten carbide, is we need tungsten. Do we need any tungsten? No. We need virgin tungsten carbide. I love to say this, virgin tungsten carbide. Why? Why do we want virgin tungsten carbide? Because it has the highest purity. It is the most pure tungsten you will find. This is certified. So certified means that it really is recorded, that is kept to be as pure as it needs to be. Now, why is that important? We don't work with recycled tungsten. It's much cheaper, but recycled tungsten carbide can lead to micro fissures in your burr. Micro fissures in your burr can lead to breaking off of parts of your burr. You don't want that. It's not practical. It destroys the burr. Quality-wise, not ideal. And also for the operator, it's not really comfortable. It's not really pleasant if you have a part breaking off. So for us, essential virgin tungsten carbide. That's already an important part. The second thing that we have is you have, of course, the shank. And the second thing that we need beside the shank and the tungsten carbide is in the middle there's a small metal disc. The small metal disc is called a trifoil. A trifoil, which is a mixture between brass, copper, and silver, and is braced in between the shank and the burr itself. Now, what does that do? It gives a certain tolerance. It means that the burr will not break as easily as with a burr that does not have that. Again, it's comfortable, it is more safe, and it gives a better performance of your burr. It makes a huge difference in comparison to lower quality burrs. So these are elements that are absolutely important. Now, this trifoil disc made out of copper, brass, and silver needs to be braced in between there. Now, this is a time-consuming and laborious work. So it is, of course, leading to the safety of the burr, better performance of the burr in comparison to a normal, lower quality burr. Now, to show you a little bit those different parts, I got a couple of samples prepared to show you that. First of all, we have the stem. You see, this is the stem of the burr, just this piece of metal. There we go. This is your stem. Then we have, again, in a close-up, there we go. This is the virgin tungsten carbide. There we go, untreated. Then finally, and this is really tiny, tiny. There we go. You see this small spot, this small disc. This is this tin foil of this trifoil disc that is placed between the shank and the burr itself. And then finally, we get to the burr itself. This is the burr itself, untreated. It's uncut. So you don't have a cut yet. Now also Tyrolit produces the wheels to cut those burrs, to shape them, to create the geometry necessary for different applications. Now these wheels that we produce are called StarTech. So also there we provide the tools necessary to work on those burrs. So that's kind of interesting as a fact. Now, I've been talking about those construction of those burrs. So how does that work? What does that do? And the best thing to do is actually show you that I will try to destroy this burr. Now, in order to destroy this burr, I'm going to put it in the vise and really tighten it, because in order to destroy that, I'm going to use a hammer. And I'm going to try to break the carbide burr. So to show you the safety of the burr. Of course, being put in a vise, I'm going to use a lot of force. That might be that it doesn't work entirely as I hope or anticipate. I tried it before and it worked, so I hope it will work now as well. So I'm going to try to destroy the burr and we'll see what happens. There we go. It didn't bend entirely as I hoped for. So you can see that it bends. This was the effect where I was going for. I used another vise for that one. So, but it shows you what happens. It bends. It doesn't break. And that makes the difference. It's a safety aspect, a comfort aspect, and a quality aspect from the constructions of those burrs with the trifoil. It makes a difference. And this is the best way to show you that. This is what it does. It helps to create a better product in comparison to lower quality ones. So this is, of course, because of that trifoil. As I mentioned also, we have different cuts. We have different shapes. We have different sizes. Now, the one used the most throughout the whole range of different cuts that are available is the MX. The MX cut is a traditional cut. This is a perfect example of an MX cut. You can see it's almost like diamond-shaped cut. That's basically the cut used the most in metalworking. Now, the reason why, because it's universal. You can use it on a lot of different materials. It works universal. It's very user-friendly, means it vibrates less. Also, it causes a reduced risk of loading of the burr itself. And also, as you could see, because of that shape, you will have a finer chips in comparison to another cut. So this leads to this being the cut used the most throughout the different applications. This is really a benefit of that cut. It's comfortable, it's universal, it's nice to work with, it's easy. So it's user-friendly, basically. So another element when working with carbide burrs is speed. Speed is essential. Speed is important. For that, we have prepared a small slide that you will also find in our catalog from the pages of 121 up to 124. You will find all the technical information on the carbide burrs, including recommended speeds. Speed according to the diameter of your burr, according to the material you work on, and also to the speed required for that, for the diameter and the material that you work upon. Now, the reason why I cannot stress this enough, that you need to pay attention to that, is because there are straight grinders on the market like this one that is running at a speed of maximum 7,000 RPM. And if you look on those tables, you will see that there is occasionally, you see a speed going up to 80,000 RPM. So there's a big difference. So, and that's why it is important to use the right power tool for the burr and the application that you are working on. So this is important. The best way to show you that is to do a small demonstration of an identical burr on a low speed straight grinder, and the same one on a high speed straight grinder, and see if we notice any difference. If on the way it works, vibration, if it starts fighting against the operator, to show you that. So first of all, I'm going to try the one with the low RPM. RPM is about 5,000 RPM running. As you can see, it gives the impression that it is working, but I need to fight against it. I need to hold this a bit better, keep control of that. It's not allowing me to work very comfortable. Sometimes it actually starts to jump away, which can lead to the cause of breaking off of the teeth of the burr itself, which is not ideal. So this is, for me, not ideal. To me, more or better would be this one. So running at 30,000 RPM, smaller burr, this is absolutely how it should be. And let's see how that works. You hear the difference. You hear the difference during the work-in. You can see the difference during the work on the workpiece itself. It's day and night. If you try both of them yourself, you try that out, use a slow speed and a high speed, it's a huge difference. The moment you've tried it, you're never going to go to a low-speed machine for carbide burrs. You will go for the machine with the correct speed for your carbide burrs, because it makes a huge difference on speed of work and comfort. So these are important elements. Now, things that you need to avoid working with a carbide burr. What do you need to avoid is, first of all, a mechanical shock. This is not good. This is a mechanical shock, so this is not okay. Now, that's a joke, of course. That's not something that's going to happen like that. But a mechanical shock can be you throw your machine somewhere in the corner, or it drops off the table, stuff like that. You need to avoid. It's not ideal. So let's try to avoid that. The second thing is a thermal shock, overheating. When does a burr overheat? Is when you plunge into a workpiece, you dive into it and you go way too deep. Then you start to generate a lot of heat, and that can cause damage to your burr. So you don't want that either. So this is also something you avoid. Jamming your burr into a groove, into a corner, into a channel. Again, it's going to fight against you, it's going to struggle, and you will have damage done on the burr itself, and it's going to be extremely difficult to work with something like that. So try to avoid jamming your burrs into grooves or corners or of your workpiece. So if you use your burrs correctly, they work like a dream. They're fast, they're easy to work with, you can go to difficult to reach places, absolutely nice. Now, we're getting to a favorite of mine. Favorite of mine is, when we're talking about birds, kind of strange. A favorite of mine is two interesting cuts called a steel cut and a stainless steel cut. What is different? There's a new geometry that has been designed in developing those burrs, those cuts. The first one, if we talk about it, it's the stainless steel one is the inox cut. Inox cut is extremely aggressive. It will take off a lot of material. High stock removal rate means you will have less production time needed to do the work, and you also will have less downtime when using an IC burr. Also, if with this new stainless geometry, the inox geometry, you will have an excess of plus 35% on stock removal in comparison to a conventional burr. 35%. So longer life and faster. The second one, the steel one, is an aggressive form. It's an aggressive cut. It's going to be having larger chips that's going to be removed. It's going to have a higher stock removal rate, and it will lead to an excess of 30% plus on removal, on lifetime, in comparison of a normal conventional carbide burr. That is quite a bit. That is quite a bit. So 35% on this IC stainless steel cut or 30% on the steel cut, that is quite a lot of that's a huge difference to me. Now, the best way to show you that is to work with two burrs the same size, and one has the MX cut, the one used the most, the one that I also used just before to make the comparison with the low speed and the high speed. So the same one there, this one, and the steel cut. So if we can have this in a little bit of a close-up, then you might see the difference in the teeth there. You see that? If you would put an aluminium cut next to it, you would say, oh, it's almost like for aluminium. It's not true. It is for steel. So you can see the normal MX cut and you can see the steel cut. It's a huge difference in size of the cut itself. It's just by looking at it, you can anticipate that there is indeed going to be a higher stock removal rate with the SC cut in comparison to the MX cut. But that's now a lot of talking already. Let's put them to the test. Let's show you what that SC cut can achieve. So first of all, the MX, the normal one. As you can see, this goes well. So how do you work with a burr like that? You use light pressure, like a continuous movement, light pressure going like that, and then it works ideal. This, you don't force it. If you start forcing it, it's not going to work ideal. So allow light pressure and you can continuous move back and forth and you will have an excellent result. Now do the same thing with the SC, with the steel cut. Well, it was, let me get rid of that. To me, from where I was standing, it is visible. You can see that it goes much faster into the material, that it takes off material much faster. You can also see the chips flying off. They're larger. They're larger in comparison to the MX cut. So this is really a burr that has been designed to have a high stock removal rate, fast working, coarser cut. Really, absolutely nice to do that. Now, one of the things that makes that burr standing out, that steel cut or stainless steel cut, the inox cut, stand out is also on applications. I'll give you an experience that I had, I think about 2 years ago. We visited a metal construction company, and they're working on Hardox. Hardox, this kind of material, very tough material. It's very wear resistant. It's hard to work on, and they needed to work on that. I think they were construction of parts of excavators, stuff like that. So they went through about 50 burrs a week. Oh, that's nice. That's nice. That's a nice customer. So now those 50 burrs, most of them didn't last very long. They had breaking, they had the breaking of teeth, they had overheating. So they had a large consumption of burrs, and they couldn't get the full potential of the burr to be used. So we tried our steel cut. We gave a sample, we provided a sample to try out and see what would happen. So they tried that. Now what turned out is that first of all, they experienced that they could work faster. They could work faster in comparison to the burr they had. Not only that, they could work much longer with the steel cut on the Hardox material. So they were able to reduce the number of burrs below 20. That's a huge difference. This is exactly the difference what I'm talking about innovations, about developments like the SC, the IC in comparison to a normal MX cut. So it gives a difference. Now, the reason why I've taken that part of Hardox is also to show you that the same burr that I used before with the SC cut will absolutely work very well also on the Hardox material. So that I'm putting my money where my mouth is, basically. There we go. As you can see, also there, not a problem. It's a confirmation what I said. It's also a confirmation of the experience we had at the end user in order to work on Hardox material, on tough material. So these are already interesting things that is possible, what you can do with carbide burrs. Now, for the next step, I would like to talk a little bit more about the shapes, the different shapes that are available. All right, because you will see that there are a lot of shapes available, as you will see on the next slide. So I'm not going to demonstrate all of them. I'm going to take a couple of examples that I will show you, because I need to change every time the burrs. I only have so many machines, so I need to change them, and that of course takes always a little bit of time. Now I'm going to show you a couple of shapes. Now if you need to find out what shapes are available and also why those shapes are designed like that, what you can do with them, again I need to refer to our catalog, where you will find examples of applications where that specific shape is going to be used for. So this is something you will find in there. The one that I will show you now is the first, is the 52 R&D. It's a smaller one designed for grooves. So you have a prepared groove and you need to work a little bit on that. That's where you're going to be able to use that. This is the one. I'm not sure if you, there we go. There it is. You see? It's like a small disc with teeth on the side, designed to go into a groove, to work on a groove. Now, of course, I prepared a part like that. So there we go, the 52 R&D. Please forget about those numbers. Don't learn them by heart. You will find them back into the catalog where you can see, aha, this is that shape, and you can work with that. It's much easier. I do the same thing. So, as you can see, you can work in a groove that has been prepared, where you need to do a little bit of work. Also, what I was trying to do next to it is create a groove myself with the burr itself, which is perhaps not ideal, because that's exactly what I said you need to try to avoid, is going deep into the material like that. So, but it was just to show you what is possible with a small burr like that what can do. What it can do. So these are things, it's not to underestimate the power of a carbide burr. So that's kind of cool. That is kind of cool. The second shape that I would like to show you is the one, a cylinder with the a top cut as well. Combination of the normal cut and a top cut as well that can be used on certain parts. The one that I'm going to use it on is, first of all, on the radius in here. There we go. So working on that radius there. And then after that, I'll flip that part around and show you also where the top cut can actually be beneficial. Very nice removal, flattening of all that. There were irregularities after the welding, so we can take that off very, very quickly, very easily. Now, the other side is a bit trickier. There we go. Yep, there we go. To work on that part also with the top cut that we have there. So here you have a combined action of the cylinder itself and the top cut as well that works on that edge there, on that straight part over there. So there you have a combination of the two sides of a burr being used on an application like that. It's like snowing here. So another one that is kind of special is a special shape like this. There we go. If you look at that one, there you can see that it is really a special shape called the 52 SKN. So it is designed for what? To work on or breaking the edges on a plate or on a cut-off part that can be used in shipyards where they do round up or break the sharp edges you have there. So this is what I'm going to try to do with this one. Quickly change. Hoppala. Power back on. And now I'm going to try to break those edges on both sides at the same time. This should be possible with this burr. I know it goes very, very quickly, but it's exactly what it does. It breaks the edges on those plates. So if I would use that on another part as well, it does exactly the same thing. It is designed for working on parts like this to break the sharp edges that you have on there. So it is a very specific design, a very unique design for applications like that. So if you have a company or a customer that has a lot of parts that they actually are working with, or a burr or a flap disc or anything like that, where they just need to get rid of the sharp edges, this is a possible alternative. Also for larger parts where they need to actually create or destroy, get rid of those sharp edges, get it more radius. This is something that helps on that. So far, I haven't seen any questions, so that means that's, let's hope it's a good sign. Another one that I would like to show you is a special cut for aluminium. Like for aluminium, happens to be that I have a part of aluminium, of course. If I would use the MX cut or the SC, it is not ideal. It is not ideal. The reason why is because it's going to load up. It's going to fill up the grooves of the carbide burr. So in order to show you what that means as a difference, there we go. I have two burrs, almost the same size, that you can see. There we go. And then you can see the one for aluminium and the normal one for steel or stainless steel. So this is, you can see there's a large difference in the opening, the grooves of this burr, designed for aluminium or softer non-ferrous material. Quickly change the burr again. And let's show you how it works on aluminium. Of course, power back on. If I continue like that for 5 minutes, we have Winter Wonderland over here. So this is really, and if you look at the burr now itself, you don't see any loading up of aluminium on that part. None at all. So this is absolutely necessary. If you work on softer, non-ferrous material, you need to have this open structured burr in order to have no loading up at the burr itself, giving you the lifetime and the performance of that burr. Now, in all my excitement about showing you and telling you about burrs, I forgot a small thing. I forgot about a tiny burr that we have as well, because all the things you've seen here, they all been pretty large. There's pretty big burrs that you can see here. So they're all pretty large. But there are also small ones, like this one. Like if you look at that, you might even think that it's something that is used at a dentist. Well, it's not the case. It's not going to be used at a dentist. It's going to be used right here. And that can be used in precision foundries. That can be used on precision parts where things need to be cleaned up. And in this case, we have our Tyrolit logo on a key holder that I want to clean up a little bit between the laser cut parts that we have on there. Let's do that nicely in the middle, that it's very well visible. There we go. Does sound like a dentist. So as you can see, also small burrs are used for different applications, difficult to reach areas, smaller parts, more complex parts. You will find stuff like that being used as well. And I'm happy I didn't forget, because I almost did. I almost did. Now, a last thing, a last development that we had this year is the coating of burrs. Now, it's a new coating technology that will lead to what is called high performance coating, or HPC. Again, great, HPC, and then different shape and so on and so on. So high performance coating, it's a coating that we brought onto our burrs. Now, what does that do? It will lead to the fact that the burr gets harder, that it gets more resistant, and it will have a much better lifetime in comparison to a burr that is not coated like that. It will give you a smoother surface. It will have a better chip transportation in comparison to burrs that are not having this coating. Now, what if we would combine that with an innovative cut, a new cut geometry? Then we get to the point where we get double lifetime in comparison to a traditional MX cut. That's it. So double lifetime in comparison to an MX cut. That is substantial. Now, another thing that is pretty cool is it looks also cool. It is unique for Tyrolit. It is absolutely, look, there we go, the blue part, there we go. This is the coated product, the HPC carbide burr with the new innovative cut. So gives you this gives you a different performance, which I'm going to show you in a minute. Now, I see that there is a question. These look very aggressive for deburring. How can you be sure you are not going to remove too much material? Well, depends a bit on what you want to achieve. Yes, the things I'm using are extremely aggressive. Now, I'm not sure to which burr you specifically refer to, so let's assume that you say it's the one for aluminium. There we go. The one for aluminium, yes, that looks aggressive. But you're gonna have, you need to work on aluminium, you need a burr that has an open structure. Why? Because you're working on soft material, otherwise it would clog up. If you would use the normal, the finer one like an MX, it will clog up, it will load up, it will die. It will not work anymore. So that's the reason why you need to have this open structure. It may look very aggressive, too aggressive, but you can determine how much material you take off by applying pressure or light pressure or almost no pressure. So this is going to give you that difference. If you say, no, I'm not talking about aluminium one, I'm talking about the IC or the SC cut. If that cut is indeed too aggressive, this can be, then go to the MX. MX is less aggressive. You will have a better, more control. It's easier to control in comparison to the SC or the IC. But if you're looking for fast stock removal with a burr, the SC and IC cut are going to be absolutely ideal. Now, if you're looking for fine tuning, not too aggressive, slower, MX is the one that you're looking for. I hope this answered a bit your question. If not, let me know. You get my email below, so if there's anything, you can let me know. And there we go. Thank you. Thank you. You can absolutely send me an email, and I'll try to help you as good as I can. All right. So the last demonstration for today is with the new coated product, the HPC burr that I have here to work in the corner and try to clean up, remove a little bit of that weld that we have in there. So as you can see, it goes fast. It takes off material fast, and also it's nice to work with. It's comfortable to work with, and because of the coating, because of the new geometry, it will give you a double performance in comparison to a traditional MX cut. So this is what I wanted to talk to you about today, about carbide burrs. I hope it brought a little bit more understanding about what are carbide burrs, how are they made, what is important on the construction of carbide burrs, what affects the lifetime, the quality of a carbide burr, because this is what we want to do. We want to achieve the best quality for the best performance. This is what we do. So we chose to go with, again, I can say the word again, virgin tungsten carbide, which I think is kind of cool. But besides that, the quality is absolutely outstanding. So this makes a difference in performance, in lifetime, in cost reduction, and so on and so on. And there is another question that came up there. For these two, which is better, air or electrical power? That's a good question. The reason why I use both here is because in the field you will see both being used. The benefit to me especially on this one is I have a variable speed. I can adapt it, which makes it easier, which is of course with an air power tool not that easy. It's a bit more difficult. There you need to have the right tool for the right speed, diameter, and the part you're working on. So it depends on preference. It can also depend on habit. I like air power tools. I must admit, I like them. They're practical. You see that? It's practical. You can maneuver it very nice. It's easy to work with. It's not that heavy. If you use an electrical, it's already heavier. That's the downside. Again, can be preference. I like air power. I know that if I need to have something at a different speed, a higher speed, I need to have a different tool. I don't have the possibility on changing speed on this particular air-powered straight grinder. So performance-wise, they both work. There is no, I wouldn't say there's a difference. There's performance-wise, they go, if you have the right speed, they'll go, they'll work, they deliver. So I cannot say I prefer electrical over air power because of performance. It's more, I like, this gives me a lot of liberty in maneuvering with the tool itself. Okay, so that's basically the end for today. Don't forget that we will have a next Tyrolit Tool School November 10th, and that is looking now, that will go about wire brushes. So from my side, thank you for being here. Thank you for participating. If you're looking this later on at Vimeo or another platform, thank you for watching. Thank you for checking up on me and on what we can present to you. And I wish you a very, very pleasant afternoon. Stay healthy, stay well, be well, and looking forward hearing from you or seeing you or you seeing me next time. Take care all and all the best. Cheers. Bye-bye.